Hello everyone, welcome my dear students to the world's first school-based live tuition, so specially designed for Birla 8th grade. Hi Kritik, how are you doing? You're from Birla 8th grade itself, right? Isn't it Kritik? Yes. So Kritik, sir, is it on speaker or what? I'm unable to hear the sound of Kritik. Yes, now I can hear you, Kritik. So in your school, which chapter is going on, Kritik? Exams are happening. So revisions are happening, right? So right now, any kind of term exams or annual exams are coming up real quick. Next is annual exams are coming up. So which exams are started right now? You told right, one exam started. Periodic test 2 has started. Okay, fine. So is the science exam done, Kritik? Science exam done already. Okay, great. How is it, Kritik? You found it easy, tough? Be honest. Not that tough. Pretty easy. Okay, great. So Kritik, over here, with respect to physics, okay, I'm here to take a major remedial section. I'll not be your regular physics tutor. I just want to give you a major remedial session with respect to the important doubts, queries, and all with respect to physics. Got it, Kritik? So, which chapter you need for revision? Light chapter. So, we'll revise light, right? That'll be better for you, right? Okay. So, we'll go ahead with the revision of the light chapter. So, Kritik, what are your hobbies? You do art and sports. Great. What is your genre of art which you love the most? Come again? Come again? Like, I didn't get that. Oh, there's combination of it. Great, great. Okay, with respect to sports, which sport you love the most? Football. Who is your favorite footballer? Messi. Great. So we need to fight if in the upcoming session, if I'm coming, for sure. I'm a diehard Ronaldo fan. You love Barcelona, right? All of my friends were teasing me since Barcelona won against Real Madrid yesterday. I'm a diehard Real Madrid fan, Ronaldo fan, and all. But anyways, Kritik, yes, let's see. Which position do you play? Attacking midfielder. Great then. Fine then, Kritik. So can we start? Can we go ahead with the revision? Whatever the concerns you have, you can ask me openly. Okay, I'll be there to support you. And even if a new tutor comes, like I told, right, I'm coming in way just to take the revisions and all. So whatever the concerns you have, speak up. Okay, teachers will be very friendly with you, right? Make use of the tuitions. Got it, Kritik? Yes. So with respect to light chapter, let's discuss the core concepts. So before you go, we have a question with respect to introduction. So if it's fine, yes. Suppose you are in a dark room. Can you see the objects in the room? Can you see the objects outside the room? Explain. What do you think? In dark room? Why so? What do you think? What is the reason? There is no light. If the presence of light is not there, we'll not be able to see the object, right? So, in your 8th grade textbook, you're following NCRT itself, right? Okay. So over there, the introduction part, it is mentioned if the room is dark, then the object which is in the room reflects as there is no light in the dark, right? The reflects no light, right? It's dark. Hence, the person inside will not be able to see the objects in the room where there is no light. But Kritik, do you think the person inside the room will be able to see things outside if it's daytime during the day? They can see the things outside, right? Even if they are inside a dark room, because light is present outside, isn't it? But the objects outside the room can be seen easily if light is present outside. Only if light is present outside. Isn't it? Yes. So I'm going ahead. Laws of reflection of light. Okay. So, Kritik, do you learn the laws of reflection of light in school? Any idea? You have learned it. Okay. Tell me the laws of reflection of light. Let me check how much you know it. First one. Two laws. Correct. Great. Very good. Angle of incidence, angle, not angle. The incident ray, reflected ray, and the normal will lie on the same plane. That is the second one. Correct. What is the first one then? Angle of incidence will be equal to the angle of reflection. Isn't it? Great then. So over here, if I'm considering a smooth surface, okay? Let's say I'm considering a smooth surface, okay? So on this smooth surface, if we have light falling on it, okay, it'll make an angle with the normal. Okay, now, yes, Kritik? Yes. So Kritik, over here, an N is marked. What is that? What is the normal? Normal means what? It makes 90-degree with the reflecting surface. Okay, so that is the normal. So this is the incident ray. Incident ray. Okay, and this is the reflected ray. Okay, so the angle may between the incident ray and the normal is the angle of incidence. Got it? The angle between the reflected ray and the normal is called the angle of reflection. Got this? Every single student I've seen might be doing this mistake. Some of you guys will be taking the angle of incidence over here, angle of reflection over here. Do you think it's correct? No, right? So we can't take the angle of incidence and angle of reflection over here, isn't it? So we have to take the angle of incidence and angle of reflection exactly between the normal and the incident ray. The angle of reflection should be exactly between the reflected ray and the normal. Correct, Kritik? Yes. So based on that, we can say the angle of incidence will be equal to the angle of reflection based on the loss of reflection. So give side heading loss of reflection and write these two laws, Kritik. So let's learn it right away. So in remedial session, no, what will we do? We'll not cover the concept real quick. We'll just make sure we are learning each and every topic. Got it? It's like a learning session. Got it? Yeah. Not teaching session, not concept covering session. We need to make sure that the concepts we are discussing is learned right away. Yes. So once you're done, I'm gonna go ahead. So, Kritik, the second one you understood, right? The incident ray, reflected ray, and the normal to the surface are in the same plane. That is on the same surface. Okay? That is, this incident ray, reflected ray are all of them are lying on one single same plane or same surface. Got it? Yes, in real life, if you do an experiment, if you take a torchlight and a mirror, The incident ray, reflected ray, all of them will line one single plane. It will not go the other way or a different angle. Got it? Yes. So we have a question now. Two mirrors meet at right angles. A ray of light is incident on one at an angle of 30 degree as shown in the figure. Draw the reflected ray from the mirror, from the second mirror. How will you draw it? Try it to think. Two mirrors are meeting at right angles. The ray of light is incident on one at an angle of 30 degrees. Yeah. So to draw the reflected ray from the second mirror. Yes. So once you're done, let me know. So over here, you can see that the incident ray makes 30 degree. Yes, yes, Kritik. Yeah, two mirrors here, but reflected ray you can draw it right away from here, right? Yes. Again, it'll reflect. Correct. Correct. So over here, what will happen? It has like over here, it'll make an angle of 30 degree, right? Because on a plane mirror, the angle of incidence will be equal to the angle of reflection. Isn't it? So what can we consider? We can consider a normal over here as well, isn't it? Now, if this angle is 30, this angle will be how much? Alternate interior angles. In mathematics, you might have learned. If this is 30, it'll also be 30. What is this total angle with respect to normal? Yeah, this angle will be 60. What will be the total angle with the surface and normal? 90 degree, right? Normal makes 90 degree angle with the surface. Since the total is 90, this angle will be obviously how much? 60 degree. Isn't it? Yes. Draw the reflected ray from the second mirror. So from the second mirror, you can easily draw a reflected ray like this at 60 degree angle with the normal. If this is 60, this is the angle of incidence, right? Isn't it? And this is the angle of reflection in the case of this mirror. This is mirror 2 and this is the case of mirror 1. In mirror 1, the angle of incidence is 30 and angle of reflection is 30. In mirror 2, the angle of incidence is 60, angle of reflection is 60. Got the concept, Kritik? Yes. See, this is the answer we get. Show me what you have drawn in your book. Let me see. You got the same answer in your book or you have randomly tried it? Angle. Okay, great, great. The angle of reflection you have written it properly. Very good, Kritik. Yes. Yes. Image formed by a plane mirror is virtual behind the mirror and enlarged. Or virtual behind the mirror and of same object, same size as the object. Real at surface of the mirror and enlarged. Real behind the mirror and of same as of the object. Which one is the correct answer? It is the multiple choice. It is a multiple choice question. Very good. Kritik is like, sir, don't even discuss anything with me. I've already learned this chapter. Isn't it? In the case of a plane mirror, obviously the image form will be virtual. And it'll be behind the mirror for sure. And the size will be same as of the object. That is, if we look at the plane mirror every day when we go to school, we'll set our hair, check everything, right? Is it? So what happens? The image formed on the mirror will be the exact same size as of us, right? Size the object and the size image formed on the mirror will be of the same size. So option B is the right answer, isn't it? Image formed in the case of a plane mirror is virtual behind the mirror and of the same size as the object. Very good, Kritik. I'm excited. I'm like, okay, I don't even have to giving some extra tips. He's like, sir, I know the answer. What are the types of reflection? We have major two types of reflection, Kritik. Major two types of reflection. What are the two types of types of reflection? Regular reflection and irregular reflection. That is, if you're considering a reflection in the case of a smooth plane surface, it is regular. If you're considering a rough surface or irregular surface, it is irregular reflection. Got it? Smooth surface and rough surface. Can you see the animation? This is how we have the regular reflection and irregular reflection. In the case of a smooth surface, regular reflection. That is, the incident rays and reflected rays will be parallel to each other. Can you see? Both incident rays and reflected rays are parallel to each other. In the case of rough surface, are they parallel to each other in this case? No, right? The reflected rays are not parallel to each other, isn't it? So reflection from a smooth surface like that of a mirror is called regular reflection. Got it? Regular reflection takes place when light is incident on a smooth, polished, and regular surface. Understood, Kritik? Yes. Now we can easily answer, right? If someone asks what is regular reflection? What is it? Smooth surface. What and also you have to mention about the reflected ray. What will happen to the reflected rays? No. All the incident rays will be parallel to each other, and all the reflected rays will be parallel to each other. Not incident ray and reflected ray, they are not parallel to each other. Right? They make an angle. All the reflected rays will be parallel to each other, all the incident rays will be parallel to each other. Correct? So you don't have to mention about the incident rays. Just mention all the reflected rays will be parallel to each other in the case of regular reflection. Yes. Now, in the case of rough surface or irregular reflection, all the parallel rays reflected from space plane surface are not parallel. The reflection is known as diffused or irregular reflection. Yes. So make sure you don't forget the term, because irregular reflection can also be termed as diffuse reflection. Okay, it is caused by the irregularities in the surface. So note down in your book, diffuse irregular reflection is also called as diffuse reflection, or else you'll forget this. Remaining points you'll remember for sure. You are able to answer. I'm so glad and happy about it. Yes. When it comes to national team, you love Argentina more or what? They're obviously Messi fan. Yes. So have you met Messi from Qatar for the world, like during the World Cup and all? You are in Qatar right now, right? Yeah. Like not personally, at least from the stadium. Did you see him playing or what? Okay. So you went to the stadium or what? Oh, great. So you went to watch the game, right? With your friends or family? Family. Great, great. Fine. You saw Neymar as well. Oh, great, 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 great. Fine then. So, first Brazil match you have watched. Great, great. Yes. So you have like which siblings you have? Younger brother, elder brother, sister? No one. Just one. Yes, I'm also single child. I don't have any siblings, but I have a lot of cousins to like eat my brain. Yes. Fine. So let's go to the examples which you're gonna consider. So mention against each of the following whether regular or diffuse reflection will take place when a beam of light strikes. Now, if you have a polished wooden table, what will happen? Regular or irregular reflection? Obviously, regular reflection, right? Isn't it? Now, chalk powder, Irregular, right? Chalk powder will make irregularities on the surface. So we'll have diffused. Okay, I'll give heading like regular and diffused so that we can just put a tick mark. Okay, regular and diffused. So which category will come? We'll put a tick mark. So polished wooden table, obviously regular reflection. Chalk powder, diffused reflection. Cardboard, diffused rough surface. Yes. A marble floor surface with water. What do you think? Regular for sure, isn't it? Marble floor surface with water will be slippery smooth. If you walk on it, you will slip off and fall down, isn't it? So a marble floor surface with water is obviously regular reflection. A mirror, plain mirror, regular for sure. Plain mirror is very smooth. Piece of paper, piece of paper. Diffuse, right? Piece of paper means obviously it'll have irregularities, not a complete paper, just a piece of paper. So it'll be irregular. If you tear a piece of paper, you'll understand, isn't it? It'll make irregularities, right? Isn't it? So diffuse reflection. So we can check out each one. A polished wooden table is smooth, so regular. Chalk border irregular or diffused. Cardboard irregular or diffused. Marble floor regular. Mirror smooth surface regular. Piece of paper may appear smooth, but it has many minor irregularities. So diffuse reflection takes place. Isn't it, Kritik? Yes. Now fill in the blanks in the floor. A person 1 meter in front of a plane mirror seems to be dash meter away from his image. That is, a person is in front of a mirror. Yeah, let's say this is the person in front of a mirror. Okay, the distance is 1 meter. So from the image formed behind the mirror, they're asking how much distance away from his image. That is, the person is how much distance away from the image. What will be this distance, Kritik? Virtual image for sure. Distance they're asking. The distance from the person to the mirror is 1 meter. So distance from the mirror to the image will be 1 meter itself. So the question is, a person seems to be 1 meter in front of a plane mirror, seems to be dash meter away from his image. So from the image, how much distance the person will be at? The total distance is 2 meter. So the person will be 2 meter away from his image. But from the image, from the mirror, it's just 1 meter. But from the image, he is 2 meter away. Got it? Now, if you touch your ear with your right hand, okay? If you touch your dash ear, okay, ear is not mentioned, in front of a plane mirror, it will be seen in the mirror that your right ear is touched with your left hand. So when you touch your dash ear with your right hand, how will we see in the mirror? Think about it. So if you touch your left ear with right hand, on the mirror it will be seen as you are touching the right ear with left hand, isn't it? So this is if you touch your left ear with right hand. Very good. And you will see in the mirror as right ear is touched with your left hand. Now, size of the pupil becomes dash when you see in dim light. Like pupil means you know it, right? We say, right? Like between the iris, there is a black color structure. Yes. So the pupil size will dilate or contract when amount of light is less. It'll dilate, it'll get enlarged, right? Isn't it? Dim light means what? Presence of light is not there. So pupil will be dilating because more light should enter our eyes. Then only we'll be able to see the things, right? So as the pupil becomes enlarged when you see in dim light. Got it? The night birds have dash corns than rods in their eyes. Have more corns or less corns? Less corns for sure, right? They will have less corns than rods in their eyes. What are corn cells and rod cells? Sensitive to dim light. Corn cells are sensitive to more bright light. Okay, night birds should have good vision, right? Even in dim light. So less corn cells will be there. More rod cells will be there so that they can see easily at night. So that's why it's mentioned night birds. Yes. So night birds have fewer cons than roads in their eyes. Okay, Kritik is like, sir, all the answers are given, but still we need to discuss, right? We should have an idea about this. That is, person 1 meter in front of a plane mirror seems to be 2 meter away from his. To touch your left ear with your right hand in front of a plane mirror, it will be seen in the mirror that your right ear is touched with your left. So if the pupil becomes large or enlarged when you see in dim light. Night birds have fewer cons than roads in their eyes, or lesser cons than roads in their. Got it? Yes. Image formed by a plane mirror, we have discussed, it is virtual behind the mirror and of the same size as the object. Now, how many images of a candle will be formed if it is placed between two parallel plane mirrors separated by 40 centimeters? Two parallel plane mirrors I am considering. How many images will be formed? Infinite number of images will be formed, right? Why did they give 40 centimeter then? What do you think? Obviously to confuse us. Got it? In the question, the student will be thinking, okay, 40 centimeters given. Where should we use it? We don't have to use it. This is a tricky question. If it's mentioned, the mirrors are placed parallel to each other, the number of images formed will be infinite number of images. Got it? So the number of images formed will be infinite over there. Very good, Triti. What is the angle of incidence of a ray if the reflected ray is at an angle of 90 degree to the incident ray? Find it. Reflected ray and incident ray make 90-degree angle. Yeah. What is the angle of incidence of a ray then? Obviously, these two angles will be 45 degree, will be half of 90 degree for sure. So the angle of incident ray will be 45 degree. If the reflected ray is at an angle of 90 degree to the incident ray, then the angle of incidence is 45 degree. According to law of reflection, the angle of incidence and angle of reflection are equal. Therefore, both the angle of incidence and angle of reflection is 90 by 2, 45. Very good, Kritik. Now, what is a kaleidoscope? Have you seen a kaleidoscope in real life, Kritik? You have you have tried it. You have made a kaleidoscope, or you have bought it, or like you saw it somewhere. Got it. So kaleidoscope is nothing but a tube containing mirrors and piece of colored glass or pebbles creating beautiful patterns. So if you do not write this, just go through it. Now, see, this is just an example of how you see inside a kaleidoscope. As the viewer looks into one end, light entering the other end creates a colorful pattern. Okay, so when you make a kaleidoscope, you'll understand the regular session we have discussed. That is, from one end light will be entering, from the other end also, from one end we'll be checking, we'll be looking at it, from the other end light will be entering, and creates beautiful colored pattern due to the reflection of mirrors when rotated. Inside the kaleidoscope we have three different layers of mirrors, right? Isn't it? Like three like mirrors will keep with a particular angle, like a triangle you might have seen inside a kaleidoscope. Yes. So, and also an interesting feature of a kaleidoscope is that you will never see the same pattern again. As we move the kaleidoscope, these pebbles or the patterns inside it will keep changing. Is it? There is the like if you're putting glass pieces or pebbles inside it, when you rotate, the position of it will keep changing, right? So what does that mean? You'll never see the same pattern again as we rotate. Correct, Kritik? Yes. What is dispersion? Next concept is not other than dispersion. What is dispersion, Kritik? Any idea? Not separation. Finally, a topic which Kritik have no idea about. I'm happy. I'm glad. So Kritik, spreading of light. Yes, very close. That's it. So in the case of dispersion, what happens? Okay, sunlight is white light, sure, just white color light. Okay. Does it comprise of any other colors? Sunlight is actually white, but still it comprises of 7 component colors or 7 constant colors in it, right? Have you heard about Newton's disk? That is, we'll have a disk. filled with 7 colors in it. When you rotate this disc, we'll see white light, isn't it? We'll see not white light, white color, isn't it? When you rotate all the 7 colored discs together, what we'll see? We'll see white color over there. Why? Because white light comprises of all the 7 component colors based on Newton's disk concept. And the phenomenon of dispersion is splitting up of white light into its 7 component constant colors. That is none other than dispersion. Correct, Kritik? It consists of 7 colors. Splitting up of light into its constant colors is known as dispersion of light. An example of dispersion is rainbow. Rainbow is a natural phenomenon showing dispersion. Correct, Kritik? So note this down real quick. Once you're done writing, please let me know. Done, Kritik? Yes. So understood all the points. Sunlight is referred to as white light. But still, it consists of what? 7 constant components. So this white light will be splitting into 7 component colors, cause of a phenomenon called as dispersion of light. The best example or best natural example is rainbow. So in your physics lab or in your science lab, have you done this experiment using a prism, glass prism? Through you haven't done it. So through a glass prism, if light is passed, will get 7 component colors out of it. So glass prism will be undergoing, like inside the glass prism, dispersion phenomena will be undergoing over there. So in nature, in the case of a rainbow, we see dispersion because, like, when will we see rainbow, Kritik? Any idea? Immediately after a rain shower, right? So what happens over there? There will be raindrops in the atmosphere. So these raindrops present in the atmosphere will act as the prism, isn't it, over there? So this through these raindrops, when light is passed through it, this light gets split up into 7 component colors or constant colors. That is the reason we say that rainbow. In the case of rainbow, it is the best example for dispersion. Who is acting as a prism over there? The water droplets in the atmosphere. That is why it is generally seen after a rain shower. Got it? Next question is, draw a label sketch of the human eye. In your textbook, you have it already, right? Do you know to identify the different parts of a human eye, Kritik? Okay, okay. So draw a rough sketch of a human eye in your book, quick. And mark the parts like ciliary muscles, iris, lens, cornea, optic nerve, and retina. You should know how to draw a rough sketch of a human eye. In your exams, you'll have a direct question. So function of each of it we are going to discuss. So draw a rough sketch in your book like this. You're good at art, right? So it'll be easy for you, I guess. Generally, students will be teasing me, sir, you are like Picasso. You're close to Da Vinci and all. I'm like, bro, please don't tease me. Okay. So, Kritik, over here we have different parts of the eye, right? The outermost part of the human eye is none other than cornea. That is where the initial refraction of light happens. That is, light rays will be bending from the cornea itself. Okay, that is the outermost transparent region where light enters the eye. Yeah, and inside the eyes, over here it is not marked. Over here we have the pupil. Okay, over here we have the pupil. If you want, you can mark it as well. Pupil will be between the iris. That is, in the middle of the iris, you will have the pupil. Okay. So you might have heard that brown eyes, blue eyes, and all, isn't it? Yes. So the iris makes that color of the color for our eyes. Okay. So this region is the iris, and this black color structure is the pupil. Got it? This region of the eye is the iris, and this black color structure is the pupil. So light will enter to the eye through the cornea and it will pass through the pupil, and iris will be helping to adjust the size of the pupil. The size of the pupil will get enlarged if it is dim light. It will contract if it is more light coming up. If bright light is entering our eyes, what will we do? We'll constrict, we'll squint our eyes, right? Is it? So iris is responsible for it. Now, once the light is passed through the pupil, it will pass through the lens. Over here we have the lens, and so as to support the lens, we have the ciliary muscle. So in the case of light to fall on the retina, the size of the lens will be changing, right? That is, if you are reading a book, if you change the position of the book, our eye lens will be adjusting the focus, right? So sometimes our eye lens will elongate, sometimes will contract. Who is responsible for this? Who is doing this job? Contraction and relaxation. Ciliary muscles. So ciliary muscles will be contracting the lenses or elongating the lenses. So it is the action of ciliary muscles will be helping to do that. So when the lens is elongated, the focal length can be increased. When the lens is constricted, the focal length can be decreased. Got it? So it is based on at what distance we are using or at what distance we are trying to focus in on. Got it? Understood the function of ciliary muscles, understood the function of iris, lens, cornea. Lens actually converges the light ray. It acts as a normal convex lens. Okay. So here, in the case of a human eye, we'll obviously use a convex. I hope you know that. Is it? And on the retina, yes, if you will forget this, you can note it down. In human eye, it's not like in human eye will bring a convex lens. Our eye lens is actually acting like a convex lens. Understood, Kritik? Yes. Yes. Images will be formed on the retina. Got it? So over here we'll get an inverted image. We'll get an inverted image over here on the retina. And the signal will go to our brain, and our brain will be perceiving the actual image form. Got it? And signal from the retina will be passed on through the optic nerve to the brain. Optic nerve actually takes the signals from the retina to the brain. Got it? That is the function of an optic nerve. And on the retina itself, we have this cones and rod cells. Cone cells, rod cells, and all are present on the retina itself. Got it, Kritik? Got a basic idea? And we have a sport over here, if you don't know, that is none other than blind sport. That is at the junction of the optic nerve and the retina, we have a spot called blind spot. Over there, the images will not be formed. There is no receptor, light receptor cells over there. So the image formation will not be possible over there. Very good, Kritik. Kritik is like, sir, don't even come to teach. I have revised all these concepts. Yes. The eye has a roughly spherical shape. So cornea, that is the outer cord of the eye. You do not write this. Just go through it, Kritik. We'll learn it right away. Yes. The outer cord of the eye is white. So it is tough so that it can protect the interior of the eye from accidents. So its transparent front part is called the cornea. So the cornea, what is its duty? It is responsible for focusing most of the light that enters the eye. Yes, correct. The case of iris, it is behind the cornea. We found it. We find a dark muscular structure called iris. Iris is that part of the eye which gives its distinctive color. I told, right? Blue eyes, red eyes, not red eyes, okay. Brown eyes, yes. So your iris color is normal black, right? Or brown? Oh, dark brown. Okay. Everyone is having dark brown generally, I guess, isn't it? Dark brown. Can be light as well. Yes. Some of my friends are having cat eyes. Scary, right? Yes, cat eyes. So in the iris, there is a small opening. It is called the pupil. And what happens? Iris controls the amount of light entering the eye. Why? Iris will contract and dilate. So in the same way, pupil will also contract and dilate. Iris is like the ciliary muscles of the pupil. For lens, it is ciliary muscles. For pupil, iris. So iris controls the amount of light entering the eye. Possible? Yes. So eye lens behind the pupil of the eye, it is a lens which is thicker in the center, which means convex lens, right? Eye lens will be thicker in the center, thinner at the edges, isn't it? We know it already. So the lens focuses the light on the back of the eye on a layer called retina. On the retina, the images will be formed because light will be focused on the retina, isn't it? Now, the retina contains several nerve cells. There are two kinds of cells, con cells and rod cells. Con cells are sensitive to bright light. I told you, right? Isn't it? Rod cells are sensitive to dim light. You will forget this. So, Kritik, note down this point. Write cons and write rods. And note down cons are sensitive to bright light, rods are sensitive to dim light. Remaining points you'll remember, I know it. But the points related to cons and rods, know them down. Once you have jotted it down, let me know. And over there, the sensations felt by the nerve cells will be transmitted to the brain through the optic nerve. It is from sensation over there from the nerve cells will be transmitted to the brain to the optic nerve. So on the brain, we'll be able to perceive the image, isn't it? The actual image, if I'm looking at you, the actual image formed on my eyes inverted. Your head's down, legs up. Imagine. But thank God we have brain, cause that we are able to see the object clearly. Like erect itself, not inverted. Got it? Yes. So a student has difficulty reading the blackboard while sitting in the last row. What could be the defect the child is suffering from? How can it be correct? Last row. Okay, the student, he or she is not able to see the board. That's what I'm saying. It's not long-sightedness. It is short-sightedness. Short-sighted means what? The student can see only nearby objects. The student will be unable to focus distant objects, isn't it? So if a student is sitting in the last row from the blackboard, obviously a lot of distance will be there. The student is not able to see the blackboard because the student is suffering from myopia or short-sightedness. That is, the student will be able to see only the nearby objects. The distant object cannot be seen. Okay. Since the child cannot see the distant objects like blackboard writing clearly, he is suffering from the defect of vision called myopia or short-sightedness. Myopia can be corrected using spectacles containing concave lens of optical. So concave lens is the correction for myopia. You have learned it, Kritik? You remember this? Great. Explain how you can take care of your eyes. Major steps. Reading should not be done in bright light as well as in dim light. Okay. We should visit an eye specialist at regular intervals of time to check our eye status. If any small insects or dust particles enters our eyes, immediately what do we do? We rub it, right? Is it good for our eyes? No. Do not rub them, but clean them immediately with cold water. Okay? Kritik, the answers for this question seems to be easy. Okay, we all know all these points. But when you write it for the exam, no, we'll be forgetting some. But in real life, we know it. Got it? So make sure you're able to write it for the exam as well. Okay. So we should avoid direct exposure of our eyes to the sunlight. We should avoid it. Okay. While reading, there should be a distance of at least 25 centimeters between the eyes and the book. Should not keep a book very close to our eye. Minimum 25 centimeter distance should be there. Yeah. And we should avoid direct exposure of eyes to sunlight. Will you look at the sunlight directly? No, right? But I have tried when I was in 8th grade. You never tried? Once. Okay. So Kritik, like why you use glasses? Because eye lens power is less or what? Okay. Not cause of myopia or hypermetropia, right? Oh, great. So we have learned how we can take care of our eyes. Major points, you all know it, right? Very simple points. Isn't it? We do it in real life. So write a short note on Braille system. Have you heard about Louis Braille? Very last question related to this chapter. Okay. So Braille system, who is Louis Braille? Visually impaired himself. He is the what did he say? Great. Okay. So the most popular resource for visually challenged person is none other than Braille system. So Louis Braille himself, a visually challenged person, developed a system for visually challenged person and published it in 1821. That is the Braille system. We know it. But how is it used? What is the like major points related to it? Okay. So there is a Braille code for common languages, mathematics, and scientific notations. Okay. Many Indian languages can be read using the Braille system. That is, for each different language or different patterns for scientific notations, for mathematics and all, there are different patterns in Braille system. Right, Kritik? Where are you from, Kritik? You're from India, right? Where in India? Kerala. Where in Kerala? Mahaveli, Kerala. Which district is it? I'm from Kasaragod, the border district in Kerala. Yeah, great. So, Braille system has 63 dot patterns or characters. So, each character represents a letter, a combination of letters, or a common word or grammatical sign. So, can you see the different dot patterns for the letter, for the alphabet C? We have a different pattern. For A, different pattern. T, different pattern. So, that's how we write the word kind. For and, a different pattern. For comma, also different pattern. Right? Can you see this Braille paper, the patterns written in Braille paper? Got it. And these dots will be slightly raised. So the people who are visually challenged can touch it and identify, okay, this is C, this is A, the dot pattern. And they are like, okay, cat, C-A-T, cat. Okay, it'll take time, but it'll be easy for them once they learn the Braille system. Okay, this point, note this down in your book because the remaining points you'll remember. Louis Braille invented the system and all those points you'll remember. But Braille system has 63 dot patterns or characters. Each character represents a letter, combination of letters, a common word, or a grammatical sign. Note this down, quick. Or else you'll forget this. Done, Kritik? Yes. So patterns when embossed on braille sheets help visually challenged persons to recognize words by touching. Yeah. To make them easier to touch, the dots are raised slightly. I was saying the same, right? Isn't it? So that's how they identify. See the dot patterns over here. You can see that all the dot patterns are raised slightly, isn't it? So that when they touch, they identify the letters. Got it? Have you seen a braille paper in real life? No, right? You have seen it from where? Oh, okay. Oh, in lips also you might have noticed. Lips, great. Yeah. So I've seen a braille paper in real life in National Library in Bangalore. I've seen it. So visually challenged people learn the braille system by beginning with letters, then special characters and letter combination. And the different methods depend upon recognition by touching each character has to be memorized. That is, when they touch it, they'll memorize. Okay, this pattern is for the letter A. This is the pattern for letter B. So they have to memorize the pattern. Then only they'll be able to identify the letters, right? That's how they do it. Now, braille text can be produced by hand or by machine. Okay, typewriter like devices and printing machines have now been developed for braille system. Okay, that is how the braille papers and all have been. They have been creating all the ages. Correct, Pratik? So got a basic idea of all the major concepts with respect to this chapter. Any doubts, any concerns before we wind up, Kritik, you can ask. No, right? With respect to light chapter, all the concepts pakka clear, crystal clear, no doubts. Okay, great. So in school, you have to score maximum in light chapter. Okay, she should be like, yeah, Manoj sir has discussed all the more major questions. So I'm so thorough with it, isn't it, Kritik? So nice to meet you, Kritik. We'll meet soon. I'll be coming up for some revisions and all. So, anyways, I'll not be a regular tutor. So don't worry. So Kritik is next sir. Even if you come, it's fine. So Kritik, we need to discuss more about football as well. So can we wind up the meeting then? Okay. Great then, Kritik. I'm gonna wind up the meeting. So no concerns, right? Before I wind up? No concerns. Okay, one second. Kritik. Yeah. So that's all for today, Kritik. Thanks for joining. Good night. See you. Bye bye. Yes. Bye. Yes, Kritik. You can leave the meeting. Good night.